Welcome to the webinar. You have entered as an attendee in listen-only mode.
All right, let's go ahead and get started. So hello and welcome to today's webinar presentation titled Make Analytical Data Available to Everyone by Overcoming the 5 Biggest Challenges, brought to you by Dremio. Before we get started, I have a few housekeeping items that I need to go over. First, if you have any questions for our presenters today, post those into the questions panel so we can get to them after the presentation. Secondly, if you experience any technical difficulties today, please post a message into the panel and I will work with you to resolve those issues. Last on my housekeeping list, today's presentation is being recorded and it will be available shortly after the webinar concludes. At this time, I'd like to pass it off to our moderator, Louise from Dremio.
Thank you. And again, thank you for joining us for today's webinar, Making Analytical Data Available to Everyone by Overcoming the 5 Biggest Challenges. As mentioned, my name is Louise Westaby, and I'm a Senior Director of Product Marketing here at Dremio, and I'll be your moderator for this webinar. I'd like to introduce our speakers. So our first speaker is Dr. Claudia Imhoff, who's the CEO of Intelligent Solutions and the founder of Boulder BI Brain Trust. Claudia is an internationally recognized expert on analytics, business intelligence, and the infrastructure to support these initiatives. She's also co-authored 5 books on these subjects. Our second speaker is Isha Sharma, who works with me here at Dremio and is the Director of Product Management. Previously, Isha was in product management at Teradata, where she was focused on developer experience. She's now working at Dremio on tackling data challenges and working with data simple. So with that, I'd like to hand it over to Claudia.
All right, wonderful. Well, my thanks to Louise. Thank you very much for the kind introduction. And of course, thanks to Dremio for giving me the floor for at least a few minutes so that I can talk to you and set up the 5 challenges as I see them. I'm going to start off, though, a little bit architecturally, if you don't mind. I certainly hope that's suitable with everyone. If you know me, you know that I cut my teeth on architecture, and so architecture is near and dear. Let's start off with a different kind of architecture, though. I'm calling it the extended analytics architecture. I first published this, I think in 2016 or so, as a way of introducing that all analytics do not all belong inside of an enterprise data warehouse. Yes, a lot of therapy helped me say that. Instead, there are 3 massive areas of analytics today and the technologies that go along with those areas. And that's what the extended analytics architecture is all about. Quickly, if we go up the left-hand side of the architecture, we start with the operational systems. Their data goes into the data integration platform. That's our good old ETL, ELT, whichever way you want to call it. It pumps out the integrated trusted data into that, yes, there it is, traditional EDW. The EDW in this case, though, is it always has been really, a production-ready environment, known queries with known sets of data, trusted sets of data. And then, of course, on top of that are the analytical tools and applications that use that data to create the reports, the widgets, the dashboards, and so on and so forth. All that trusted data, KPIs, customer analytics, production-ready, stuff that has to be run on a routine basis. Starting on the right-hand side, you're going to start to see some new things. The first one is that real-time analysis platform, streaming analytics, if you will. Real-time analysis on real-time data as it's streaming into our environment. That's the second area for analytics. So we're talking about analyzing it first and then storing it as opposed to storing it and analyzing it. Now, the data from the operational systems and the real-time analysis systems could be used for the third analytical area, and that means that the data would go through a refinery. the data refinery down there. It's not, some people call it data wrangling, data prep, whatever you want to call it. I happen to call it a data refinery, where it knocks the rough edges off of the data streaming in. Perhaps it's even something like Twitter feeds or IoT or whatever. And then it's going to go into the investigative computing platform, the third analytical area. The investigative computing platform, I call it that. Some people call it the data lake. I think Dremio would call it a data lake. The idea there is that the refinery gets the data, preps it for the analysis, perhaps by data scientists, perhaps by advanced analytical programs and so forth. All those things, of course, sitting in our analytical tools and applications area. Now, the only box I haven't talked about is the one on the far right, and that's all that weird stuff that we're now bringing into our analytical environments, other internal and external structured and variably structured information. Like I said, IoT, Twitter, social media, whatever it is, maybe it's even bot data that we bring into this environment from the outside world. So those are the three big investigative areas, right? The traditional production workhorse, the data warehouse, the investigative computing platform, that exploratory experimental area for our data scientists, the data lake, if you will, and then the real-time analysis platform for the streaming analytics, again, streaming data. So the one thing I do want to get across, though, is that this architecture is a logical architecture, just like the old architectures, the corporate information factory and the bus architecture. Both were logical architectures, and so is this one. How you physically implement it is entirely up to you, your technological choices, your personnel, your skills, and so forth, your budget even, and your analytical needs. It's an interesting world today because you could choose to implement both the EDW and the investigative computing platform or the cloud data lake on the same technology. Now, you may need some logical partitioning there, separation of the data perhaps for performance or other reasons, or you can put them on different technologies altogether, your choice. You also may choose to implement the architecture in the cloud, on premises, or some kind of mixture of the two, some kind of hybrid environment. In any case, though, all of the data and the analytical assets derived from that data, the reports, the visualizations, the algorithms, the models, whatever it is, all of these things need to be made available to anyone with a need to know. Anyone who has a decision to be made should have access to the decision-making helpers here. And the data needs to flow much like, let's say, water throughout your cities and your house, or electricity through the grid. It should flow as easily as it possibly can from one area to another. Now, the way it flows is this last architectural diagram. What I've done is taken the architecture itself, taken out the boxes of the ETL or the data prep, and made them flows. So let's look at these flows. There are two types that you see in this environment. The first one are the physical movements. If I'm using ETL, for example, to get data into my traditional EDW, you see the big green arrow at the top. If I'm doing data prep and I'm moving information into my investigative computing platform, my data lake, you'll see the green arrows going into it. And then, of course, the arrows go out and ultimately end up with the analytical tools and applications. Now, there's a bunch of blue arrows there, and let me talk about those for just a moment. Data virtualization, the ability to layer a semantic layer, if you will, over this entire architecture so that I can bring data together virtually, not physically, is very popular in this environment. If I want to combine, for example, data from my operational systems with data from, excuse me, with analytical results from my traditional EDW, then I'm going to use some form of virtualization rather than physically moving the data and mashing it together. I will virtually do it. That semantic layer, if you will, that brings the data together virtually. So I have two mechanisms, two flows going on in this environment. Now that's going to become important when we start to hear from Isha and what's going on inside the Dremio environment. So keep the flows in mind. All right, so let's talk about the 5 challenges to making all of this data available to everyone. Here are the 5. The first one's determining what to store and what to share. We'll talk about that in a fair amount of detail in a moment. The multiple data storage mechanisms, deployments. If I've got multiple cloud deployments, if I've got some on premises and some in the cloud, how do I bring these things together? How do I make all of that data available? Undocumented or unknown data dumps. We've all experienced them. Interference with the critical operational applications. That's where data virtualization can run into some problems. And then finally, understanding the data content and monitoring its usage. That's an important characteristic, an important challenge. And it's hard, it's difficult. We'll talk about that one too. All right, determining what data to store, what data to share. First of all, please recognize that there are very different analytical processes going on here. Again, the EDW doing the production reports, the dashboard widgets, the daily, weekly, monthly analytics, those trusted analytics like KPIs and so forth. That's going on in our EDW. It's a very different process. Experimental, exploratory queries or analyses, many of those one-off things like, did this ever happen, or will this ever happen, or what happens if we change this? Those unplanned examinations of data and events that the data warehouse simply cannot support. That's the data lake. That's the investigative computing platform. And then, as I mentioned, the real-time analysis of streaming data requiring sub-second response time, much like the operational environment. Alerts, alarms that are dependent on instant analysis, split-second decisions, for example. All kinds of things that are going on in our streaming analytics environment. The different processes require specialized data, meant just for them, right? They really do require that the data be set up so that they can do their jobs. Can they occur within the same database? I would say that 2 of those, the store and analyze, are certainly up for grabs for being in the same environment. The odd one is the streaming analytics, probably not going to be mixed with the store and analyze environment. Do they need some kind of data separation or partitioning to help them run, either logical or physical, to make sure that their responses are good and that they don't impact the other sets of queries that are going on in that environment? So something to think about there. The other thing is that some data is very sensitive. We've got a lot of personal data in our databases all over the place. So we need to make sure that we're not doing something that is counter to, let's say, regulations or compliance. Should the data be monitored separately and differently from non-sensitive data? Can I even monitor my sensitive data? Should it be handled differently? Yeah, probably. Is there encryption involved, security, other specialized processes? Does it even belong in the cloud? In some cases, there are certain compliance and other regulatory issues that say, you know what, your data can't leave your 4 walls, or it certainly can't leave the country. So does it belong in the cloud to begin with? So storing all the data in one database, now we're talking about data engineering really being very critical, very important here. Finding and eliminating duplicate data. One of the nice things about getting all the data together in a single instance is now I can see what I've got in one big bucket, right? Do I have redundant data that I shouldn't have? Why am I continuing to put redundancy into this environment? Can I streamline it? And we all know that duplicated data comes into our data warehouses and our data lakes, often without our knowledge even. It's copied to increase access or specialized processing or redundant because of a misunderstanding. I didn't think we had that data, so I did another extraction, and oh, look at that. Now we have 2 sets of that data. Can we streamline the entire process, the data integration processes in particular, by removing the redundant transformations and extractions? Eliminating the orphan code. I've got this code running and it doesn't go anywhere. Can we get rid of some of those well-worn user exits and maybe automate the whole process? And of course, is there metadata even available to tell me what's in my storage mechanism? Can I see what's going on? Boy, we can do so much if we can just get rid of the redundancy there. I'm going to talk about it again. It's important. Multiple data storage deployments. Can or should the data be stored across different cloud providers? You know, if one cloud was good, then two must be better, right? What happens to performance, security, governance, all of that good kind of stuff when you spread the data across multiple cloud providers? Data replication or extracts between the cloud providers. Now we're moving data between clouds and that sort of thing. Probably not a good practice. Again, you're getting the redundancy, the copies, the extracts, and so forth. And you know, as soon as you get an extract in one cloud and do the extract and move it into the other cloud, it's going to be stale, right? It's old. It can cause problems with the enterprise's security and privacy policies. Do the two clouds have comparable security and privacy, or can I install my privacy policies in both of them? It can also cause great problems with governance and regulatory compliance. Are you sure you know where all that sensitive data is? And it does increase the complexity of the analytic environment. The more connectors, drivers that are needed, the more complex the environment becomes. And the more complex in development and maintenance as well. If I've got multiple things going on, redundancy all over the place, I have to be able to maintain them. I have to be able to protect them and connect them and so forth and so on. So a lot of problems when we start to have multiple data storage deployments. Performance can degrade when the data is spread out as well through the hybrid environment. I talked about data virtualization. When you start to virtualize data in very different environments, you're depending on the connectivity there. For example, if I'm virtualizing data that's on premises with data that's up in the cloud, a lot of the performance depends on how good my connectivity is, my internet speed and so forth and so on. We can get increased traffic across the hybrid environment. So that means potential bottlenecks, potential security breaches. And then, of course, the bulk transfer mechanisms can be slow. ODBC, JDBC, they were really good when we were dealing with small BI requirements, a report or a widget or a dashboard or something like that. But those protocols, if we're talking about massive amounts of data, the well-known big data, for example, those protocols may not transfer data fast enough. So we may need a different mechanism to transfer the data even between these environments. Number 3, undocumented, unknown data dumps. This is when the data lake becomes the data swamp. Please don't do that to the data lake. A simple forklift of all data into a single repository is also not a terrific idea. It may be expedient. For example, you may have a mandate that says, move our data warehouse to the cloud. Fine, let's forklift it. Is that a good thing? Well, not really. What got forklifted in? If it's an older data warehouse, 5 years or older, you know it's got a lot of user exits. You know it's got a lot of redundancy. You know there are extracts of extracts in there. You know there's stale or forgotten data that has never been used. We just keep stuffing it into the data warehouse because somebody asked for it and then they no longer used it. Non-standard data sets. We lost a lot of our standardization over the years, perhaps. And of course, the quality, the low quality data sets. Do we know what we're bringing in? Can these problems be mitigated over time? If the expediency is get it into the cloud, fine, but what can we do in the future? Well, could we take a slice of the analytical data, clean it up, document it, standardize it, do whatever we need to do, and then move on to another slice of data? It's kind of like changing the tires while the car is moving. It can be done, I suppose, but it's a heck of a lot harder. Number 4, interference with critical operational applications. This comes into or this gets into the separation of compute and storage. Marvelous move. It really was wonderful. Compute and storage were tightly coupled for operational purposes, transaction processing. We liked having them connected then because it made transaction processing really fast. Low latency mattered in those systems. We had to ensure the persistence and integrity of the transactional data and the transactional processing. So storage was kept as close as possible to compute. These needs don't exist, though, with our analytical data, do they? We are not talking about a transactional system here. We're talking about an analytical system. So the separation of data from compute power is, in fact, possible with our analytical data. With the data stored in the cloud, the analytical applications can then run in a separate environment and use the data that they process, access the data that they need separately from the actual processing. Cloud compute and storage does still need to work together, though. Even if they are independent of each other, there is a balance. We have to make sure that the communication is strong between compute and storage so that we don't get unnecessary data movement, data duplication, and higher latency rates because we aren't monitoring our compute versus storage. They aren't in balance. Sometimes analytical applications also need operational data, and that's where we can kind of get into some problems here. For example, streaming analytics or embedded BI services or other real-time analyses may be functioning in the operational environment. If so, these unplanned for usages of operational data can interfere with our operational applications' performances. That's a no-no. You don't slow down operational systems. So we need to have dynamic scaling. It is a critical capability. Does the architecture support the seamless communication and compatibility while separating storage from compute? Can the enterprise grow compute capabilities while keeping the storage capability, the storage amount relatively constant, or vice versa? In the analytical world, typically the data storage is the one that changes more often than the compute power does, but we need to be able to at least scale one up while leaving the other one where it is. Last one, and then I'll close out and hand it over to Isha. My last one is understanding content and monitoring its usage. So critical these days. Many of the challenges that I've talked about come from the inability to understand what's in our stored data, to monitor its utilization. So we need usage metrics. Who's using it? What application is using it? And the statistics that go along with those to supply answers to many of the critical questions. Do I have redundancy? How can I streamline this environment? Do I have sensitive data? How often is the data being used? If it's not used very often or not at all, then why do I continue to store it? Maybe I need to archive it. What's affecting the performance of the application? Do we get spikes? Is there seasonality? Is there something going on that causes my applications to have poor performance? Can you detect that unused, stale, or redundant data and simply get rid of it? And then I mentioned utilization is really useful for archiving, but it's also useful to understand how to store the data. Data that's hot, that's used every day. Yeah, we better store that in our hot storage, right? Our ready-to-go storage. But other data that's used maybe once a month, maybe we can put it in a cooler storage, warm storage, if you will. And if it's really not being used, then let's archive it into cold storage. It's important to study the usage metrics over time. Like I mentioned, we can see over time that there is perhaps some kind of seasonality or other time-based changes. Every month-end close, we see that big old spike. Yeah, that happens, so let's plan for it. Or every start of the summer, we see a spike in fill in the blank. Let's plan for it. Is there also seasonality or other time-based changes even in the compute requirements, not just the data storage, but even in the compute requirements themselves? There can be seasonality there. All right, I'm going to wrap it up now with my last little bit here. Benefits of moving to a centralized data storage. Well, first of all, if it's all in one place, you know where it is, right? Faster access to analytical data. That means we can perhaps support self-service better, those people that want to serve themselves. A faster time to value for all kinds of analytics, planned and unplanned. I get to the result faster. Reduce costs for storage versus compute. Again, scaling each independently from the other can be very cost effective. Scale up, scale down when you need it. Separating storage from compute also means no idle compute resources. You're maxing that out. Nobody's sitting there idle, just waiting to work. Streamlining or re-engineering old data storage processing means lower costs for data integration, right? If we get rid of some data, we get rid of some data transformations, more efficient data processing. And then, as I mentioned, re-engineering, boy, so critical now, can create better metadata, give us better ideas of the format and the data and whatever it is, the context of the data itself, which ultimately helps with the discovery for business users. They can find the data more easily because of the context. And then my final thought, big assumption that has to be addressed here, and that is that all analytical data is in fact located in a single repository. If it's not, then many of the advantages of that single storage mechanism may be compromised. There are certainly still significant benefits to putting most, if not all, of the data there, but there may be other factors to consider when making a partial move. In other words, some of it is in this database and some of it's still on premises, something like that. Can we virtualize the data, bring it together virtually as opposed to physically, so that it at least looks like it's in a single place and I can use it as if I can analyze it as if it were in a single spot? What happens to analytical performance if there is this hybrid environment and I have to virtualize? Is there a plan in place to move all the rest of the data into that repository, or will I have a hybrid environment forever? And ultimately, will the analytical apps themselves move to the repository as well? Interesting. Now we do have compute and data together in the same environment. Can that happen too? All right, that's the end of my piece. In my minute left, I would like to encourage you to please enter your questions in the question area. I look forward to getting them. I look forward to answering them. They're always the fun part of the event. And with that, I'm going to turn it over to Isha.
Thanks, Claudia. Thanks for that great introduction on what challenges teams are facing. And before we get into exactly how we're going to solve some of those challenges, let's do a little bit of a recap of what you're facing. So essentially, data teams are being asked to do nearly the impossible, right? We're talking about data democratization. All of the data that's coming in, actually, it's more and more every day, right? That data is growing exponentially. The number of requests that are coming in are continuing to grow. And so teams are being asked to provide self-service. How do we get fast time to value for every user and all the questions they have to answer without being a bottleneck, without having to, come back to the data team to make changes to the data or refresh it every time? And then, of course, you can't lose out on that performance. You want your queries to come back quickly, especially when it comes to something like a dashboard or your BI workloads that are coming in, and people are looking at them often enough. You don't want to be sitting there for 5 minutes waiting for that to come back. But all of that is getting really hard to do, especially with the demand increasing and the requests increasing. And of course, security and governance requirements are becoming more and more stringent every day. So it's becoming difficult to put that governance in place and then manage the security across all of the data sources that you have. And your budget hasn't grown, it hasn't doubled in the last couple days, so you really do have to maintain that budget and make sure that you're not driving up costs as you're democratizing your data. And from our perspective, copies are really the biggest obstacle to data democratization, completely different sides of the spectrum. And let's dig into copies a little bit here. So the first copy that you make, which is the original, tends to be in a data lake. You put all your data there, and then for particular use cases, or maybe most of them, you're moving your data to the data warehouse. And so that's your now second copy of the data. And so even when the data is in the data warehouse, you're still not getting the performance you're looking for. So, performance optimization copies, also personalized copies to give every team the view of the data that they're looking for becomes a thing. And then, of course, cubes that are being created by data engineers, BI extracts that are being created, and as well as local files that are being downloaded for data scientists. They're all to get that performance that's needed to accomplish their goals. And essentially, as Claudia mentioned, this is leading to much longer time to value and essentially no self-service, because every time you need an update or a refresh or additional data, you have to go back to the data team and have them have them do that for you. And security and governance is a nightmare. How do you track all of those copies? How do you put all the rules in place that you need, especially with all the layers that you've created now? And I mean, when it comes to local files, those are extremely difficult to track. So how do you even begin to do that? And of course, with all of these copies, you've skyrocketed your costs, not just from a storage perspective, but also the time being spent putting these processes and pipelines in place, and all the time being spent to manage all of this. And so with the modern data architecture that's evolving, there is a solution to all of this. We started with data warehouses and Hadoop, where compute and storage were co-located. And that made things difficult because you didn't have the flexibility to scale either one without the other. And you had to sort of predict much far in advance what you were going to do rather than be able to do it on the fly, on demand. And so with cloud data warehouses, some of that does get addressed. The separation of compute and storage gives you the flexibility to scale one without the other. So if you've got more data coming in, you can scale that aspect. Or if you've got a busy season, you can scale the compute aspect. But with that, you still have the restriction of your data being in the data warehouse. You've limited yourself with a proprietary format. So with cloud data lakes, that's where you also have separation of compute and data now. So your data becomes its own tier, essentially. And that enables you to use the best of breed technologies to solve your use case. So that might be Dremio with BI workloads where you're running SQL queries. That might be Spark for some of your machine learning use cases. And that's exactly where Dremio comes in line with the modern data architecture. Dremio is that data lake query service that allows you to run your SQL queries directly on the data in data lake storage without having to have moved or copied any of that data. So like I was saying, at the bottom layer, you've got your S3 or ADLS storage component, and that's where your data stays and that's where your data lives. We've been talking about how difficult it is to maintain that single storage or have that single source of truth. But with Dremio, you can do that because you're not missing out on performance, you're not missing out on ease of use. And so your data stays in your data lake storage in that open format, whether that be Parquet or JSON. And then with technologies like Apache Iceberg and Delta Lake, we're able to bring some of those data warehousing capabilities that were previously missing from the data lake. Things like being able to update your records very granularly, so performing updates and inserts and deletes. Basically, you're able to treat the data as if it were a table, but you haven't moved it or copied it into a data warehouse. And so Dremio is this combination of a SQL engine, a query accelerator, and a semantic layer. And so the query accelerator, we've got, we very much like a data warehouse run or create query plans when you're running a query. And that's how optimizations are determined. And so optimizations such as data reflection technology is what Dremio has. Basically, it's used like an index. So that's what helps accelerate or give better performance on the query that you're running. And what's great about reflections is that you don't have to maintain any of them. Dremio manages and maintains those for you. So you would run a query much like you would anywhere. And Dremio will be the one to determine, okay, this query will benefit from running this particular reflection, and goes ahead and does that for you. So there's no management or maintenance on your part, and the reflections or the performance improvements are completely transparent to the user. And then Dremio semantic layer. One of the most key things that we have here is that ability to create different views for different teams and to organize your data in the way that you need it to do for just in one central location. You don't need to create multiple semantic layers based on the various tools that you're using. So really having that central layer and that view of what your data looks like is what enables Dremio to make data democratization easy. And then also, because you've kept your data in an open format, this allows you to use all the other services that are out there, for streaming or for machine learning. And then additionally, with all the tools that are being used out there, whether that be Jupyter for data science or Tableau, Power BI for BI dashboards, we're enabling the performance that you need there. So we have something called Aeroflight, the open source Aeroflight technology that's being used with Dremio to give you that performance that you need at the end of the day, so you're not sitting there waiting for your dashboard to load for 5 minutes. And so coming back to that point about semantic layers, right? How do you have this clean view of what your data looks like so that your end users and both the tools that they're using have access to one clear, concise, semantic layer. So before Dremio, a lot of solutions today, they've got multiple tools in the mix. They've got a tremendous amount of copies, like we were talking about, to accelerate their queries, to provide the right view for their users. And all of that sits on top of like a data warehouse, maybe even a data mart. And so there's a whole lot of complexity, as you can see here. And that essentially is leading to inconsistent data, stale data, so your results are going to be stale too. And then coming back to the data team, it's slow provisioning, and there's a bottleneck for providing access to that end user. And naturally, the governance and security challenges, if not a nightmare, they're almost impossible to track. And when you've got Dremio in place, you see that that picture starts to look a lot cleaner, a lot more organized, with a single standardized semantic layer that all your tools can access. And that's sitting directly on your cloud data lake storage. There's no need to have moved that data or copied that data out of there. So you're running directly on it. And so that does become your single source of truth when it comes to data. And obviously that gives you a lot more consistent insights and results when you're running queries or running dashboards off of this. And a faster time to insight, we've enabled that self-service access with that semantic layer. And centralized security and governance become a lot more straightforward because you're maintaining all of that in one place. So single source of truth and single point of governance and access is not so impossible anymore. And so just to reiterate on the whole no copy data strategy, with Dremio, there's really no need to move your data to the data warehouse just for the sake of it. You get the same performance, if not better, on the S3 and ADLS Cloud Data Lake storages. And you're really keeping yourself away from adding tremendous amounts of complexity and cost with performance-related copies and personalized copies. So like I mentioned, data reflections are handled by Dremio. There's no need for you to be maintaining or managing any of that. So that's a really good plus point. And then personalized copies are handled by the semantic layer, where you can really easily create different views and make sure that people are only seeing what they're supposed to be seeing. And then from an a local file or extract or import standpoint, you get the performance that you need directly with a live connection from the BI tool, rather than having to copy or download any of that data. So additionally, keeping your data, again, single source of truth, keeping your data in that data lake storage is really important. It avoids cloud and data warehouse lock-in, in the sense that when you've put your data in a data warehouse, you've locked yourself into that data warehouse by converting or transforming your data into a particular proprietary format. With Dremio, you're not doing that anymore. You're keeping your data in the data lake in open format, which makes it really easy to work with, not just with Dremio, but with a variety of services that appeal to your use cases. And on top of that, as we know, the data world, data architecture, and technologies are evolving faster than we can keep up with. So by keeping your data where it is in your data lake storage in the open format, you're also future-proofing yourself so that you're not locked out of any of the future technologies that come out to solve our use cases. And so with that, if you want to give Dremio a test drive, then check it out at dremio.com/test drive. And there we provide you a lab that you can spin up, and it walks you through how to connect to your data lake storage and how to create your virtual data sets and what it means to implement that semantic layer. And so with that, Luis, do we have any questions?
Yeah, we do indeed. So just a reminder, if you have a question, if you could please put it in the question box, and we'll get to those in the order in which we receive them. So thank you to both of our speakers. Let's go ahead and tackle the first couple of questions that have come in. So this one's for Isha. You mentioned using data reflections to accelerate queries. Doesn't that require copies?
So yeah, when we talk about copies, that you're making with extracts and whatnot, it's disconnected. They're not organized. They're up to you to manage. With data reflections, all you have to do is actually enable them in Dremio. And from there on, Dremio takes care of the maintenance and the management. So your end users are running a query on their data, on their view, much like they would anywhere else, rather than having to point directly to an aggregated or sorted table. All they're doing is pointing to the view that they have. And Dremio is figuring out, okay, yes, we're going to use this reflection because the performance will be improved. So reflections are different from unmanaged and disconnected copies, and especially, Dremio is managing them for you, so you're getting that benefit without having the extra overhead.
Okay, that makes sense. Thanks, Isha. Next question's for Claudia. In your slides, you mentioned eliminating duplicate data. How do we detect duplicate data and whether anyone is using it?
Well, unfortunately, it means you have to have some kind of mechanism to monitor utilization. A data catalog, for example, can give you that kind of information. The idea is to be able to see who is using the data, when they're using it, and how often. And that's going to take a technology that can read everything, read the data, read the queries coming in, and so forth. So something like a data catalog that collects all that metadata and all those statistics is certainly a welcomed addition.
All right, thanks, Claudia. Next question here. This one's back to Isha. With Snowflake, you don't need to create copies of the data to move between environments. Say you have a dev, QA, and prod. Each environment can use the same data. Doesn't this mean they do not have to have copies of the data?
So that's a great question. Actually, Dremio enables the same. You can point to any of your environments. But the thing with Snowflake is that you are copying your data into the data warehouse. So you've almost lost control. You've pretty much lost control of your data because you've moved it from your own account to theirs in a proprietary format to get that benefit. And so that's the difference there, is that with Dremio, you're keeping your data where it is and you're able to point to whatever environment you have. Whereas with Snowflake, if there's a particular tool that you want to connect, maybe Tableau or Power BI, you're going through Snowflake. So it's the conversation of being locked in. Your data gets locked in, and you're also dependent on Snowflake for the technologies that they support when you're trying to integrate with them.
Yeah. Isha. Claudia, next one's for you. Are there any concerns with using data virtualization? There's also a related question. Maybe you can mention a couple of data virtualization tools that are out there.
Okay, well, let's mention the tools first. That's easier. Companies like Denodo. Denodo is probably the best known for data virtualization. There are others, and in fact, there are many virtualization tools within the analytical world, especially visualization tools like Tableau and Click and that sort of thing. They all have their virtualization capabilities. The drawbacks, of course, is that this is not a physical set of data. It has been brought together and stitched together, if you will, through the virtualization technology. And that means that there's a lot of dependency on the connectivity between the databases that you're bringing data together from. So one of the holdbacks, of course, or one of the challenges with virtualization is you got to watch the performance. The second one is that it is not an ETL tool. It is not a data prep tool. You have limited ability to actually change the data and have it match between the two sets that you're virtualizing together. And the other thing is, if it doesn't have a caching mechanism, then every time you request that data, it has to go out and rebuild the virtualization. Now, a lot of the tools, like Denodo, do have caching capabilities for popularly virtualized data, so that helps a lot in terms of the performance and delays and any latency. So those are just some of the things that I think of.
All right, great. Thanks, Claudia. Next question's for Isha. Sorry, 1 second. I just lost my place. Here we go. Is Dremio somewhat similar to Snowflake? What are the key differences?
So Dremio and Snowflake are similar in the sense that they work with data. They're trying to solve the data problem and get you to insights. And the major differences are, again, that lock-in that you get with Snowflake. You're not querying your data lake directly. You are moving data into Snowflake. Whereas with Dremio, you're leaving it in your data lake, in your S3 or your ADLS, and you're querying that directly. And additionally, with Snowflake, again, you have to make all of the copies that we were talking about. You're moving it into Snowflake. There's that one copy. Then you're creating additional personalized copies, or it might be performance-related copies. And you're still using JDBC or ODBC at the end to get your BI tools to give you, to do your dashboards and whatnot. Whereas with Dremio, you're really minimizing the copies that you're making. You are getting the performance that you need with your BI tools. And again, you're open to any of the services that are out there. We haven't locked you in any way. Your data is still in open format and still very easy to use.
All right, great. There's actually a question somewhat related to this that also came in. Would you please elaborate a bit more on the open format of data? Also, wouldn't the open semantic layer add additional overhead that could increase latency?
So open format essentially means, Parquet, JSON, the format that you typically keep your data in a data lake. And the benefits to that, like I was saying, is really the flexibility that you get. When you transform your data into proprietary formats, you get stuck with that. So you prevent yourself from being able to use other services. So you're really limited in what you can do when you've transformed your data from an open format. And then the semantic layer is actually taking away a lot of the overhead that's there. When you have one centralized semantic layer, it is creating one single view that you can reference from any tool. Any user is looking at the exact same thing. So first of all, you've got one point of reference. Everybody sees the same thing. And then from a performance standpoint, nothing changes in the sense that you're still getting all of the performance that Dremio gives, whether that be via optimizations or whether that be via Aeroflight. So that sits on top of the layer of data. So Aeroflight is leveraged by your tools to then give the performance that you need. And based on some of the benchmarks we have, it gives up to 10 times the performance that PyODBC does. So you're really not losing out on, you're not creating extra overhead. You're sort of minimizing the overhead that you have.
Yeah. Yeah, I think that sounds great, Isha. And I think just to point out too, if you guys want to check that out and see how it works, again, take a look at that dremio.com/test-drive, and you can actually go experience how that works for yourself. It's a very easy self-guided tour from that perspective. All right, so lots of great comments to our speakers in here. We'll make sure we give them the feedback. There's another question here for Claudia as well. One question that I have is that the skill required at a user level goes up when the data has not been structured or simplified. Would this not make analytics a bit more specialist function?
Oh, absolutely. That's why in many cases, if a data lake is undocumented and just a dump, the only people that are going to be able to use it are the data scientists that can walk the data, can get into the underlying schemas and understand what data is there. So if we really want to democratize the data or make it available to everyone, then the data has got to be documented. It has got to be known. We have to understand its content and context. That's a mandatory step toward democratization, I think.
Yep, for sure. All right, next question. Let's see. Where are we doing? Yes, we will be sending out the recordings. I guess that's a question for me. So just to let everybody know, we will be sharing the recordings after the webinar. If you'd like the actual slides, you can also just drop us an email at hello@dremio.com, and we'll be sure to follow up with you on that. Isha, next one for you. How does Dremio compare with AWS Athena or Google's BigQuery service? Is there a data sheet that where we can see the comparison? I can answer the second part of that. We can provide you with some comparison points, and we'll follow up directly on that. Isha, do you want to kind of tackle the maybe the different workloads or examples of how you'd use Athena and BigQuery versus Dremio?
Yeah, so Athena and BigQuery are really, they allow you to query that data lake that you have, but when it comes to performance workloads, when it comes to, in particular, BI workloads, where you're really depending on those, whether that be a dashboard or a report, like I was saying, you do not want to be sitting there waiting for that dashboard to load or waiting for that report to be generated. that's where Dremio is really strong in giving you that sub-second response time when it comes to BI workloads and things like that. With Athena and BigQuery, they're great for experimentation or I guess non-production level workloads, in the sense that you're not going to get the same performance that you get with Dremio.
All right, great. Just checking to see if we've got any more questions coming in here. Let me see. This is a good one. Maybe it's a good one for Claudia to tackle, and then maybe Isha can add some color from a Dremio perspective. Data warehouse also has a function of integrating data. I have to integrate about 40 plus ERPs. Without copies, you're in an enormous amount of joins. Do you see any limitations to your virtual approach in this respect?
Yeah.
That's a lot of ERPs.
I'll just say yes. 40 ERPs, holy cow. Yeah, if you're actually integrating 40 ERPs together, you've hit the max. The virtualization is probably not going to be the way you want to go with that. You're going to look at physical integration at that point. I would question why you have 40 ERPs, but that's something you're going to have to ask your organization. But yeah, that's a massive amount of virtualization going on, and I think you've pretty much gone beyond the limit of what I would recommend for a virtualization environment.
Yeah, Isha, did you want to add?
Good luck.
Oh, yeah, that's what we're saying.
Yeah, I would say the same. I think we're looking at what's going on, and separate that out by your use cases, and see where each of those 40 belong in your use cases, I think. And that's how I would actually figure out where Dremio is good and what Dremio might not be the best for.
All right, great. Thanks, Isha. All right, I think that's all we have time for today. We're just coming up to the top of the hour. A big thank you to our speakers, Claudia and Isha, as well as our hosts at D-Zone. With that, I will hand it back over to D-Zone to wrap up.
Awesome. Thanks, Louise. And D-Zone would like to give a big thank you to Claudia and Isha for the phenomenal presentation that they both gave us. D-Zone would also like to thank Dremio for providing the audience with our two great presenters. And then lastly today, we thank you for attending our webinar, and we hope that you learned something new that will help you in your developer career. Have a great day, everyone.
Thank you.